to today's webinar. Before we get started, I would like to go over a few items so you know how to participate in today's event. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time. We will collect these and address them during the Q&A session at the end of today's presentation. So I would now like to introduce Bill McGee from SAS Labs.
Thanks, Connor, and hello, everyone. Thanks again for joining us. We have a terrific webinar lined up for you today. Tests for every branch using CircleCI and SAS Labs to continuously test CS curriculum at code.org with Brian Jordan from code.org. Wanted to let you know at the end of the presentation, we'll also be joined by Lev Lazinski, the head of technical services for CircleCI, and our own SAS Labs solutions architect, Neil Manbar, for a Q&A session with Brian following his presentation. As Connor mentioned, please submit any questions you may have using the question panel on the right-hand side of your screen. And if you're experiencing any technical issues, post them there as well, and we'll get them addressed as quickly as possible. We are recording this session today, and once it's ready, we'll go ahead and send out an email to everyone who registered with the links to the recording and slides. So if you have colleagues that weren't able to join, and you want to rest assured that they will receive the recording and the links as well. So without any further ado, let's get started, and I'll pass it along to Brian Jordan at code.org.
All right, thanks very much, Bill. Hello, everyone. Hopefully you can hear me. I imagine you can hear me, or someone else would chime in. I'm Brian Jordan. I'm a software engineer at code.org, and today I'll be kind of describing our journey towards continuous integration, continuous testing at code.org, which we recently kind of brought to the next level with integrating everything kind of on CircleCI. So I'm excited to talk to you about this, and hopefully you'll learn a little something today. So what is code.org? If for those of you who haven't heard of it before, code.org, we're a nonprofit that we're focused on expanding participation in computer science. So we really believe that computer science is something that should be taught in every school during the school day, so that literally every single student has the opportunity to learn. How do we do that? So actually, code.org started out in 2013 with something known as the Hour of Code, which is our big yearly event where students and teachers are kind of challenged to do just 1 hour of code during the school day. So especially before computer science was in any of these classrooms, you know, an hour is a manageable period of time. You go to our website and you try out a short little tutorial. Here are some of the tutorials from last year. Fun little things. You know, you have Anna and Elsa and Steve and Alex from Minecraft, and you do kind of like these drag and drop coding challenges. But to actually get computer science into classrooms, those events are great. You know, millions and millions of students and teachers tried out coding and got excited about it. But now what we're doing is trying to actually turn this into computer science in schools. And as part of that, there are all these missing pieces that we're working on. You know, you need a full curriculum. You know, there weren't super school appropriate K through 12 curricula back when we started. District partnerships, so actually working with big school districts, and I think many of the kind of the largest school districts now are signed on, and they'll say, you know what, we're going to train all our teachers. We're going to, you know, put aside the, you know, make sure that this counts as a credit, and kind of put the time and energy towards making this work. And then, of course, professional development, so actually having teachers attend kind of these workshop sessions where they learn how to teach computer science, because a lot of teachers don't have computer science background previously. And then policy change. So a lot of schools, there's a lot of pieces to this. Policy change, because a lot of states don't actually count computer science as a credit. So even if you had all these pieces ready, it was even more of an uphill battle because it was not counted as a kind of core credit like other classes. So we're making a lot of progress on these goals. You know, thousands and thousands of teachers have gone through these trainings. A ton of students and teachers are signed up and taking these courses during the school day, and our representation is really across the board, just way better representation than you see right now in the tech industry. So hopefully this will help expand participation in computer science. So what we'll be talking about mostly today and testing today is our K through 12 computer science curriculum. It's free open source curriculum that students and teachers are actively using right now. Probably we have some school day right now. They're probably sitting in a computer lab and working on learning computer science right now with it. So we'll be talking about why we're testing it, how we test it, how we use CircleCI, how we use Soft Labs during this. So I want to talk a little bit about how code.org got started automated testing. And actually, just I'm curious, and I think we have this ability to do a quick poll. I'm curious whether you attendees have done like cross-browser testing before, or even kind of like a single browser testing. So I think Connor, if you can kick off a poll there, that'd be great.
Absolutely. So the question here, are you currently doing some form of automated UI testing at your company? 3 answer choices there, so you can vote directly on your screen. And after we get a bunch of responses here, we'll go ahead and share those results with you guys.
Awesome. So actually, I'll check back in a second, Connor, and we'll see what the results are. I'll just kind of continue. So our development in 2013, 2014, we weren't doing any automated testing. So the development was very quick, right? We're working on this hour of code thing. We're rapidly iterating to get this, single hour out there, and then not really testing so much. So really, it was a matter of, when would we find the bugs? We'd find the bugs when someone says, "Hey, this thing's broken," or we'd release every so often. So a lot of times, the release would come once a week or a couple times a week. And this is actually before my time. I started right around when our UI test started getting developed. And actually, yeah, so Connor, do we have results from there?
Yeah, so it looks like the majority of everyone is saying, yes, we do cross-browser testing with Selenium. Pretty much even tie there for the first 2 responses as well.
Okay, nice. So good number of people are doing cross-browser. Good number of people are doing kind of not necessarily cross-browser, but browser test. A browser-style test, the test of their front end. Excellent. So yeah, this should be interesting. So our development 2013, 2014 was like that. So why at code.org, would we spend the time to test, and what's this, the context that we'll be working in while we're working on testing this stuff? So there's a number of important reasons here. So first of all, we're in schools, right? If you can remember during the school day, back maybe if you had computers back when you were in school, or whether you use them in school, you have students, you have teachers. They sit down and they, you spend 10 minutes maybe getting set up with getting all the students set up. They're all logging in. They're all working on that. So bugs are extremely disruptive in that environment because the teacher, they're in the middle, they're planning their entire day around, that entire hour-long class around that. If, a student's hand will go up and they'll say, "Teacher, this button doesn't work," or, "I can't get past this level," then it's on the teacher because they're really answering a lot of questions. And when there's 15 hands up, it's extremely disruptive. And yes, if you remember being in schools as well, oftentimes schools, and especially the schools, with the most need for this, don't have the latest, the latest browsers. A lot of, IE9, just in Chromebooks, you got iPads, very, broad array of technology represented. Firewalls, like YouTube's blocked in a ton of schools. So we need to figure out a way to work around that. And with all these edge cases comes a lot of things to test, and it just becomes intractable to actually end up manually testing it all. Yes, and of course, languages. We have over 40 languages supported through volunteer translators, including some right-to-left languages. So here's our Minecraft tutorial. You'll notice we have this right-to-left mode of our site. And the entire website is flipped. So all the rendering, all the SVG, those SVG paths over there, those are all being rendered the opposite way, including all the text. So as you can imagine, this introduces a lot of possible edge cases. And of course, we're using, we want to make these cool visualizations for kids so that, when they're programming the character to move around the maze, maybe it's an Angry Bird or, a Minecraft character. So we use what might be considered bleeding edge, 5 or 10 years ago technologies, which across all the different browsers is all these edge cases we've discovered. over the years that SVG rendering and canvas rendering can have. Here's another little thing we work on called AppLab, where you can basically program apps using your browser. So this shows kind of, there's a good deal of drag and drop stuff going on. A lot of this is using React. And the cool thing is that students, towards the end of their, when they're going along, they can actually transition from this block mode to an actual text mode where they can kind of type JavaScript as well, and it has this autocomplete and all that sort of stuff. Lots and lots of features and edge cases going on here. So how are we going to test all that, right? How would you test all that? It's a lot of stuff to test, and a lot of technologies and edge cases, and a lot of stuff to really cover. So how do we start Selenium testing at code.org? So one of our engineers, Brendan, actually right around when I joined in early 2014, he sat down and he just put together, very simple, just a runner, it was called runner.rb, and what it did was it spun up some browsers, and it tested a couple things out. It said click here, this should be there. Nice and simple. And I think starting simple is what I would recommend for folks who haven't done started out Selenium testing, and then kind of grow from there. It's easy to get overwhelmed when you're starting out looking at all these different technologies and things, but I think starting out simply really puts you in a good place to continue on. So what do we use? We use selenium-webdriver. So yes, as it sounds like many folks here did use Selenium, and yes, WebDriver makes it so that your Selenium test can target a bunch of different browsers, which is awesome. And then Cucumber, we'll use Cucumber, which is kind of this higher level language that lets you basically define a DSL, a kind of natural language way of describing what to do during your test, and we'll see a bit of that in a second. So how's it organized? This is our literal folder. This is where we have our test. It's /test/UI. We have a handful of different folders there. We actually still have that little runner.rb, which has now become a very powerful Ruby file / command line tool. We have our list of browsers and browsers.json. We'll see that in a second. And then we have our features, which are going to be our feature files, and some support scripts right there. So what does the feature look like? This is one of our kind of simple features. And of course, I should preface this with saying, I'm no professional tester. We're kind of getting started with this, blind leading the blind sort of situation. We've learned a lot over the years, and actually, I've learned some of the stuff that we do is not necessarily best practices, but it works, and it's gotten the test working. So sometimes it's just what you got to do. So here's one of our example features, and this is Cucumber language. We say go to this URL, rotate the landscape. So if you're on a mobile device, it says to do that. Wait to see this dialog to show up, close the dialog, and then down here, we say drag this block to another block. So yeah, over the course of time working with Cucumber and Selenium, what sort of stuff have we learned? It's extremely valuable to build up this library of steps. Sometimes it's a little daunting, right? You're looking at your website and you're like, oh, we got to drag blocks, we got to click buttons, we got to do all this stuff. These all have constituent Selenium steps and maybe some JavaScript steps. But when you build up a library of these, you end up with a lot of reusable pieces that you can use to test across your website. Here's another little lesson that we learned. I think the best practice really is that when you're writing these tests, you don't test against production data. But as we were starting out, we have this level building pipeline for creating new puzzles across our curriculum. And as a new puzzle type comes around, we'll have that. So we actually started out just testing on these levels that were there. But I think what we learned pretty quickly was that testing on real production levels is not great because things become reordered, edits get made by non-engineers who aren't necessarily running the tests every time they make a change. Although now we've mitigated that with some stuff I'll talk about soon. But what we found was it's useful to just kind of have a whole separate, just keep your kind of test stub data separate if possible, or even better would be, dynamically spin up that data when it's necessary. The other thing is with Cucumber, you can have these annotations. So for certain tests, it's just as simple as putting in as student, and the test will include a step to, create a logged in student and start running with that. And that's very useful. So who writes tests? So at code.org, actually, we all write tests. All of our engineers write tests. They write the actual full Selenium tests for their features, which I've definitely heard. I've heard companies who do it, who all do it different ways. There's definitely some value in having someone completely focused on tests. But there's also some value in having the entire team aware of how to write tests, how they run, able to do a little bit of debugging. So what actually runs tests, or who runs tests, right? You write all these tests, but when or how do they get run? So in 2015, we basically had one pipeline for tests. So we had this kind of a continuous integration system. It was basically a single server that's, it's a very beefy AWS server sitting there, EC2 server sitting there, and it says, hey, when something new is committed, run our tests. And so it, spins up these crazy parallelized tests, 640 tests and 70 threads. So 70 threads on that one machine. And I'll talk about a little bit more about parallelization with soft labs in a sec. But the one pipeline is not ideal because when you can't test every single change when you have just one machine. So oftentimes you'll be running a test, and especially if the tests take a while, you can only run one test per one full test run per hour or 2 hours, and then suddenly you have every time you run a test, it's this big bucket of commits. And I'll talk a little bit about that and a bit more. But now in 2016, we're actually running these for every commit. So we're running our unit and UI tests for every commit, which is extremely helpful in terms of figuring out what broke what when, which makes it a lot easier to avoid regressing these Selenium tests, and I think saved a lot of time in terms of having that giant bucket of potential commits that might have caused a given failure. Having that be down to one branch or one commit is extremely helpful. So what challenges did we end up facing while implementing these cross-browser tests, and how do we end up approaching them? So one of the challenges was, of course, we support many different browsers, and that was the thing I mentioned earlier. Schools have IE9, iPads, Android, Chromebooks, Firefox, all that. So what we use, as I mentioned, selenium-webdriver and our friendly neighborhood Soft Labs. Soft Labs, I imagine many of you are familiar with it. You may be using it already. It lets you spin up these browser VMs so you don't have to run your own, cloud of cross-browser things. And they have, iOS. You can just basically just say target that browser and say which browser you want. So this is our browsers.json I showed earlier. We say run on Safari, run on IE9, and if there's a new browser version that comes out that we want to cover, or let's say we want to deprecate IE9 support, we just update this browsers.json file, and everything is all great. The nice thing about especially running on this cloud infrastructure is you get the screenshots and videos and logs from your tests all kind of stored up there. And I'll actually talk about, we even access some of this data from the API to help us analyze our test performance over time. So what about testing new changes? So let's say you write a new test and then you want to make sure that it works, right? Or you're actively developing a new test. That's always important. So if you're working locally on your local dev machine, you can use chromedriver. So chromedriver is a basically it basically lets you target a local copy of Chrome through simple kind of Selenium WebDriver commands. So you spin up chromedriver, and then you can run that. The other option is you can use soft connect. That'll SSH tunnel from your dev machine, so you can be running your local web server. So if you're a developer and you're making changes to some Rails or React stuff, you have a local development copy of that running, you can just spin up soft connect, and then that will tunnel it onto SoftLabs, so you can actually run an IE9 test against your local machine, or an iPad test against your local machine, which is extremely helpful. You can even run manual sessions then against your local machine if you're working on debugging some sort of a cross-browser issue that somehow slipped by your UI test. And then big buckets of changes. I alluded to that earlier. There's nothing worse than getting and then sitting there and you're back when we had that one test machine that would run the test, and then it says, hey this test broke, and you're like, okay. And there has to be someone sitting there that's like, okay, let's spend time now figuring out what broke that. You end up with many different commits that could have possibly broken something. So then you're looking through the Git log to say, was it this one? Could have been this one. Could have been this one. Or you're running like Git bisect to figure out did it run? Did it work there? Did it work there? Did it work there? And that ended up for us actually being extremely time consuming. And we'll talk a little bit about what we did during that kind of gap period to have someone actively investigating that. But now, when these UI tests are running in CircleCI, you can tell within a given pull request, a given branch, a given commit, whether that test passed or not. So you don't get those late in the game surprises where you have big buckets of test failures. And this is the GitHub interface that we have now. So if your test passed, then hey, when before you even press the merge pull request button, that better be green, or buyer beware of merging that, merger beware. So what does it look like actually implementing something like this? So we have a circle.yml that we use we basically just added a circle.yml at the root of our directory, and we started out very simply. So actually, this is closer to what it is now. Right when we started out, it was just like run rake test in one of our subdirectories. Our repository has many different sub projects in it. So we have a Rails site, we have a Sinatra site, we have a JavaScript build system that'll run some tests with Mocha. So we just started out pretty simply, just adding run this test, run that test, and you give it the version of Ruby you want, you give it the version of Node you want, and then you can set some environment variables. Very nice and easy. So here's some kind of cool things that you might notice in here. So this circle.yml, right? YML is kind of like JSON, but tabs instead of brackets. This artifact section up on the top left there, that's very cool. So you can basically tell CircleCI, hey, after you run this test, give me everything in this folder, save it to the interface so I can analyze it later. So we find that's useful to have any of your Rails server log, your any kind of output that you're trying to actively debug right now. Oftentimes, putting those in artifacts will let you figure out what went wrong for what build, and you can analyze them later if you need to do some sort of a spelunking mission. Extremely helpful. And yeah, actually, the cool thing too is that the commands we're running ended up being, the same commands the devs run to get their builds spun up and stuff. So you actually end up breaking the build less, breaking the dev build less, which we found pretty helpful. Another thing that's cool is the dependency cache. So this is if you do an npm install, you do Ruby bundle install, it'll actually cache the build files, the downloaded files, the compiled files, or if you're downloading a binary, you can cache that. That's extremely helpful, and it figures out if you're on a staging branch and then you get branched off of it, it'll know not to not to overwrite something with a branches version of it. So that saves a lot of time just in the downloading and installing part. Another little trick, especially if you're running, some sort of a long-running UI test, Selenium test. Oftentimes, those can be a lot longer. There's a timeout parameter which says, hey, don't worry if there's no output for a while, or don't worry if this, is a kind of a long-running test, because we know it is, and you can just set that parameter there. Very cool. So here's something we found useful as my coworker Brad put in, which is very cool. Adding in more and more of these sorts of tags. So if you're using CircleCI already, or other CircleCI or other CI tools, you can often put in in the square brackets a skip, CI skip or skip CI, either one. We thought that was cool because if you're making some change and you want to don't bother testing it or test everything or that sort of thing, you can include those. So we actually we put a little tool in that lets you lets us define more of these tags, and even like test specific browsers, or make sure we run all of our tests, not just the ones for the change files, which is something else we do to save a bit of time. So yeah, if you're looking to hook up Soft Labs and CircleCI like we do, what you want to use is Soft Connect, and actually on that link there, CircleCI's docs, there's a excellent guide, basically a template for a circle.yml that actually will spin up Soft Connect, that will wait for the tunnel to be ready, and then kick off your tests. So that's a great starting point if you're looking to get started with that. And the actual, the private stuff, the username, the access key, that stuff you just put in the CircleCI interface as your environment variables, and those are kept private. So here's actually how we start Soft Connect, very similar, but we're in Ruby land when we're doing a lot of this, rather than Bash land when we're modifying our Circle logic. So we start up Soft Connect, and we make sure to kill it at the end of your session, or your tunnels will be left open. So the cool thing is, once it's running, we actually name our Soft Connect tunnels based on the Circle build number. So just looking at these active tunnel lists, you say, oh, hey, there's our CircleCI build 23203. We've run a lot of tests. And you see that there. And then what you can actually do is then when you want to look, so let's say you're running a CircleCI test, right? Maybe something's going wrong. Maybe you just want to test out your build on a certain browser, without running it locally. You can actually open up a manual Soft Labs session with any browser with, if you notice at the bottom there, with a given Soft Connect proxy. And so you can actually say, give me that build 23203. I want to target this browser against that build. And it'll just hook that up, because that's basically a localhost URL that we have there. Very cool. And of course, rebuild with SSH, or enable SSH on CircleCI. Also very useful for if you're trying to debug what's going on a given build, or if you need to test something out very quickly, like, what if I modify this file? What does it do? You can SSH in and make a quick change, and then even test it with a browser, which I think is pretty awesome. So how about analyzing failures? So actually, sometimes things don't go right. Sometimes things break in ways that you might not expect. Or let's say you're trying to make things go faster, and you want to figure out, what's our build time change over time. So we have a little tool, actually, you can check it out in our repository, called Search Circle Build, which lets you basically grep, from a given start build number to an end build number, search for a string. So let's say you have an error that was showing up in your Selenium tests, or you want to see how long this specific test took, and your output from your tests has a test time. That we found pretty helpful, and that's using the CircleCI API. It's very useful. And the Soft Labs also has a very useful API. So sometimes tests will get flaky, certain tests, whether you don't have a given weight on the thing, or there's some other sort of intermittent failure, usually due to timing. or if just it's a very complex feature with a lot of remote calls, something like that, sometimes things will get flaky. So we have a little script that will let you test the flakiness of a given test, and actually one of our engineers, Laurel, hooked that up into our actual runner so that it'll say, hey, this thing is a little flaky, maybe let's kick off a couple of those because we know it might not work. Also, in terms of best practices, I've heard varying advice as to how to approach flakiness. Some say, you know what, just rerun it a few times. Others say, rerun what? You shouldn't rerun. That's not a good sign. But you know what? Rerunning sometimes it works. Stops you from having to, halt everything when flakiness does occur. But yeah, if you can avoid flakiness altogether, I'd certainly recommend that. Good luck. And so here's another kind of cool thing that this lets you do. So once you have this all hooked up, so yeah, one of my brothers and I were thinking of doing this hackathon. So we were going to go to this hackathon, and we were saying, hey, wouldn't it be cool? When you're coming up with a hackathon idea, they say, try to think of something that's like the biggest pain, during your workday, and what's a tool that you wish existed, and hey, work on that, because that might be something other people want. So we were thinking, oh, wouldn't it be cool if you could, instead of having to, write all of these selectors and say, click here, look at this line of text, look at this thing, is the button there, what does the button say? What if you just took a screenshot of the whole page and compared the two? So we worked on this hackathon project. You like the bootstrap, clearly just a bootstrap theme there. But we hooked up there's a tool called pdiff, which lets you diff two images, and it would compare them. Turns out that's not easy. There's lots of weird ways browser rendering can go wrong, and I've heard from people who have tried using pdiff in their production pipeline. That's not always great. Turns out, of course, after I do all this work, someone tells me, oh, yeah, hey, there's this thing called applitools that lets you do that. So we actually kind of wrap that around the SoftLab browser, and that'll actually let you say during a test, hey, look at the window, upload this screenshot to your website, and tell me if there's a difference at the end of the test. We've actually found that's pretty useful to kind of bring this to the next level in terms of finding every single bug that would have occurred on a page. So oftentimes there'll be bugs that are like a second button showed up, but you didn't have an assertion in your Selenium test saying there's just there's two buttons there, something like that. There should only be one button there. So we found that pretty useful. It finds stuff like here's a little editor, a new button showed up there, an add example button, and it wasn't supposed to be there. And I probably wouldn't have noticed that for a while. This isn't one of our more often used curricula, so it might have been a while till we saw that. And here's one where a step button showed up where it shouldn't have. So yeah, that's pretty helpful in terms of finding kind of, or increasing the value of your selectors, increasing the value of looking at a given web page. So what do our tests actually look like when we're running? So I have a little recording here of a chromedriver session. I'll just run it a little bit. It's probably going to look just like crazy, browser windows opening and closing. But this is actually chromedriver running our test. So it's saying move forward, move forward. The thing I find kind of funny and cool about this is that if you think about it, it's basically a computer it's a computer program learning how to program using our program, which I think is just silly. But hey, can't have bugs in it. All right, enough of that. So not wasting time, let's not waste time. Don't want to waste time. So oftentimes, if your tests are really long or people are spending a lot of time working on these tests, like, was it worth it? And we'll talk about that. So one of the things that you want to do is, if your tests are getting very long, you want them to run faster, right? If an engineer makes a change and they have to sit around waiting for and then they want to verify that they didn't break that scenario, if it's an hour to run a single scenario or something like that, or if they want to make a big change across the website and they want to test it, you want to make sure your tests are running quickly. So in 2014, we actually kind of ran up against one of those problems where our tests were taking upwards of 60 to 90 minutes to run all of them. So back when we had that one big beefy server, even with some parallel, or yeah, so even with a little bit of parallelization, it wasn't going to that quickly. So we found was parallelizing across every single browser feature and using the ability to have concurrent VMs running at a time, which SoftLabs had. You can see the interface in the bottom there. That's test when 98 VMs are running concurrently. That is extremely helpful because then you can have, rather than just a single stream or slightly more streams, you can have a bunch of tests all running on these browsers. Basically, just by in our case, we say, hey, there's a Ruby library Parallel.map, and then we say for each of these browser features, do this, run this code, and so over time, that's end up saving a lot of time. So yeah, in 2015, we went from 60 to 90 minutes at one point down back to 20 to 30 minutes. It's always kind of a constant, you're always going to kind of be keeping an eye out for new opportunities to parallelize and speed things up, because as you run, as you hire new employees, as you write more features, you're creating more tests. So there's kind of a natural rise in the speed of tests, and sometimes there's some regression or something that made stuff go slower, but there is that natural rise, and so over time you kind of you want to have a strategy for parallelizing, similar to scaling a database. You want to be able to figure out how to shard this. So another extremely cool tool now that we have is, so right, we used to run that one main big beefy EC2 test server, but even that ended up being our bottleneck, right? Because we can spin up however many VMs on SoftLabs we want, but our server now is getting hammered by all of these browsers, and actually it's the web server side that's having trouble, not even the browser side. So what's extremely useful now is that CircleCI, you can, across different containers, you can say, for a given build, please give me 2 containers, and in this container do this, in the second container do that. So we do that, but actually you can kind of scale this as much as you want, and use however many containers you want. In our case here, it says case circle node index, so CircleCI provides this environment variable. So if you want to, there's a little bit of bash that they recommend on the site, and they have a doc on how to do that. Here we run our normal kind of unit tests in container 0, and then we say for all the other containers that exist, all the other containers that are available for this build, run the UI test. And then you put the little parallels true thing in the YAML for that test step. The cool thing there is then you're splitting out your tests, and then you can even split it out further. So if you have a bunch of different browser features, you can kind of scale that up however much you want. If your tests are really long and you need 8 containers to be able to run them all, within a reasonable period of time, you can kind of choose, how long will that take to build, which is pretty cool. So a lot of times, you'll be having like a team reflection period, and you're saying, let's look back at, the last week, month, year. How much time did we spend doing what? And you'll say, what? We had to spend all this time, writing tests, running tests. When a test breaks, investigating, why it broke, and especially if you don't have the per pull request test, it's like, I spent a whole day trying to figure out why this test broke. So sometimes someone will say, why do we even test? We're spending all this time. Why don't we just nuke the whole thing? Forget it, And it's like, it's a very tempting idea. And, when I hear that, I'm like, yeah, why don't we get rid of all of our tests? So something that, I'd be racking my brain. I'm like, oh, well, what if we just run it, just in, Phantom or Chrome or something? It's like, do we really ever have cross-browser issues? Like, come on. Why don't we just skip the whole running the IE test? Those are always, have their own flakiness. Why don't we just run the one? I'm like, oh, I could have sworn there was one in IE. I could have sworn there was one in Safari. I could have sworn there were really bad bugs. that we would have never found if we weren't running cross-browser. So what we started actually doing was keeping a bug collection as kind of a way to track over time. You know, it's almost like the trophy case of here's why we should have tests. And it's certainly grown over time, and we kind of say, you know, what was the tool that we were using that caught this test? What browser was it? Here's a screenshot of what broke, as a way of kind of validating why we do test and whether it's worth testing, and you know, whether it's worth maintaining the test. You know, there's always some sort of cost to that. So I thought it would be fun to kind of take a look into the bug collection because, you know, hey, we're an open source project. How often do you get how often do you get to look at bugs from projects? Usually people don't share their bugs. Very cool. So here's an instance where a button was removed, view data button, supposed to be there, and then it stopped being there. And that was using Soft Labs eyes. It basically just said, hey, why is this not there anymore? Here's another one where a button height changed, just very subtly, right? It's like almost even hard to tell, like 15, 20 pixels maybe. And well, I probably wouldn't have noticed that. We might have just had a smaller OK button for a long time. Here's one where a layout got messed up, you know, extra margin there. Here's a kind of funny one. If you look at the right side, does anything look wrong? I don't even know if I would notice if something looked, I don't even know if I would notice that that looked wrong when I was, you know, if I was doing a very quick look through there. But yeah, if you notice some of the text got kind of cut off there. Here was a crazy one. If you, this is flashing kind of back and forth. This is the random pixel started showing up on one of our dialogues, which I definitely wouldn't have noticed that one, but that's kind of fun. So here's a Firefox specific bug, which we wouldn't have noticed unless, you know, you were in Firefox related to SVG, where get SVG locatable.getVbox fails unless the SVG element it is applied to is already attached to another element. So yes, be careful with SVG and browsers. Do a lot of cross-browser testing. Safari as well sometimes has issues with SVG. Here was a funky issue that just suddenly kind of occurred. Chrome 50 deprecated a property, an SVG element property, and then suddenly our thing started looking mangled. That was a good one to test, to catch. You know, it's like much better to catch that early than catch that 3 months later when someone's like, why does this look weird? And you have to try to figure out how the heck that broke. That would probably be a bisect situation if I had to guess. So this is maybe one of my favorite bugs ever, just because I think it's kind of funny. It's a fun challenge for you to try to see on your own. What do you think might have gone wrong here? So here's a web page. You know, it's a mix and match type assessment question. So you drag, you know, one of the things to the right to one of the things on the left. So here's that same page later. You know, so a commit came in and we ran the test again. Here's that same page later. You notice anything different? I'll go back. Okay, here we go. So is anything different here? Okay, oh, you might see there's a scroll bar that showed up. But why? Why would a scroll bar show up? Look at that text on the bottom of the page. That's right. Apparently the entire page got slightly longer. So all the text on the page got slightly longer. So the line height was a bit of a, you know, routine refactoring with some CSS. And kind of a default page rule had gotten accidentally removed during that process. And then the line height was just completely different. That's kind of a funny one because I feel like we probably would never have noticed that, or would have just, you know, a couple years down the line said, hey, why is our entire web page slightly longer now? So in our case, who does investigate failures? We designate someone known as the dev of the day, which is kind of like a combo build master, on-call sort of thing, dev of the day. Dev of the day, it's you know, it's a mixed bag, and it's definitely gotten a lot better. Dev of the day back in the day when we had the single test machine, running the test, you'd get, the test would run, and maybe you get a failure, and then you look at, what's the difference between our staging branch and our test branch, and you say, oh my gosh, that's a lot of commits. So a lot of times, dev of the day is that process. It used to be that process of going back and forth. Oh, did this break it? Did this break it? Okay, this broke it. Let's revert that. Let's rerun the test. Oh, another thing broke the test. Did that break it? Did that break it? Oftentimes, it would be an entire day endeavor. Between that and all the other responsibilities of someone who's monitoring the build and dealing with any log side issues. Now that we have the CircleCI steps, the UI test running in CircleCI, it's much more. It's more rare now that you would see an issue come up during your dev of the day session that someone didn't catch in their branch. So I think it's with that bucket analogy, when you have the large bucket of failures, it's much harder the large bucket of commits for a given failure, it's a lot harder to figure out what broke it versus a single commit. So as we run more and more of our tests on CircleCI, we've kind of found that it's more that pain goes away more and more. So it's like, if a failure does show up on the test machine, it's like, hey, why wasn't this running on CircleCI? Is the new question, rather than boy, this is annoying, right? So extremely helpful to have that. Just about to wrap up. So what's next for us and our test suite and everything? Further flakiness investigations, of course. Flakiness is the ongoing battle for us doing work with Selenium. One of the nice things about when we can parallelize more, so there's kind of two parts, right? So if you have flakiness in your actual build step, your rake install or your npm run build sort of steps, that if you run that across 12 containers and one of them fails, you're just going to see a higher level of flakiness in general. So I think we're trying to hunt down a lot of those issues that are kind of more on our end of the stack, so as to be able to parallelize even further. Also, I think it would just be cool if we had a thing where we're running we can run our applitools eyes tests in a given branch. It'd be cool to actually see those screenshots from the results of those tests in the GitHub pull request comment, so that if you make a change and it breaks something, the notification is a visual one. It makes it a lot easier to investigate. So takeaways, what do we learn? Start small. It sounded like most of the attendees here, many of the attendees here have already started, which is great. Starting small is great. And I would also add now, if you're going to start, I would start small, but also start in every single branch and commit, because you're going to get a lot more data as to what's breaking, why. You'll be able to develop new tests easier and make changes to your test infrastructure easier if all of your tests are running in a given branch, right? So if you're working on some test infrastructure improvement, then it gets tested before you merge it in, right? Versus, versus just, YOLO merging that into your main test machine, where it might block people. In our case, it's worked out great to have everybody test. Everyone knows a little bit about the system, and periodically investing in speedups. It takes time away from other feature work, but I think a lot of the time, the impact that you get from these periodic investments and maintenance of the testing system ends up paying off in increased general team productivity. So I want to thank all the other engineers at code.org who worked on this. And pretty much everyone had a hand in touching different parts of it. And of course, I want to thank the kind folks at Soft Labs, CircleCI, and applitools who helped us get all our stuff set up, including a certain gentleman named Lev Lazinski, who we may be hearing from later. He was actually ended up helping me in certain support threads while I was getting going. Super helpful. And yeah, so I think we're ready for the Q&A. Thanks very much for attending.
Hey, thanks, Brian. That was terrific, and we've actually got some good questions to go through for the three of you.
Awesome.
We are coming up at the top of the hour, but we'll keep this open to see if we can get as many questions as addressed, maybe run 5-10 minutes a little late.
Perfect.
Brian, the first question is for you, and this goes back to about, the first third of the presentation, and Chris asks, so for each commit or each push, would you run all the tests, or did you segment them?
That's a great question. So actually, that's something that we've been kind of going back and forth on, and I think we're still trying to find the right middle ground there. So we have for a while we were running all the tests across everything, all the different browsers and all of the tests. What we found was we have issues with flakiness on our end, where just certain issues come up periodically with these tests. So as I mentioned, the more that you parallelize across containers, right, the more that these issues are going to come up. So we're down to 2 containers, and we're kind of getting a handle on that to make sure that the flakiness doesn't come up. But we were running all of the tests for a little while, and it is nice because then you aren't getting the issues coming up on the main test machine. So it's definitely a judgment call, and I think it's probably going to be a different. It's probably going to be different for every company. It might be the case that just running. I think we're still trying to find the right middle ground in terms of the cost of investigation and when do these issues come up on the main test machine when you do run them all. Because it's kind of a dial. It's like, do you want to find the failures there, or do you want to find them earlier? But with the fact that you're running more tests all the time. So I'd say ideally you run them all right. And actually we do have, but you want to think about, if a given commit only changes a couple files, what we do actually for our unit tests is we'll say, because we have multiple sub-projects, our JavaScript, our Ruby one, we'll say, hey, if you only touch the JavaScript file, let's only run the JavaScript test. So I imagine you could also probably do something like that for your Selenium tests as well, and say, if you only touch this feature or this thing that would only have a dependency on that, maybe only run that subset of tests. But yeah, I'd say that is something that I think we're definitely going to look into more as well, is figuring out what's the right kind of middle ground between running no tests and running all the tests. And I think, we've kind of been on both sides of the dial in the past, so I think we're still trying to find that middle ground. So if anyone has advice on that, please email me.
Okay, will do. Lev, I've got a question for you from Michelle. If you want to run the UI test against staging or a production server, and you want to deploy the job to trigger the tests and build a pipeline as Jenkins does, can you do that in CircleCI?
Thanks for the question. I think I understand what she's asking. Basically, CircleCI triggers based on commits by default, so we'll build every single commit unless you tell us not to. And if you wanted to do something a little bit more unique or special, then we do have our API that you're able to trigger your tests with, which allows you to build more complex workflows and direct deployments and tests to different environments and things like that. It is fully customizable, and we have robust documentation that would be glad to share with Michelle or anyone else who has more specific questions.
Okay, terrific. Brian and Neil, I've got one that I'll ask you to both address, and this is, can you elaborate? Brian, I'll ask you to address it first since he's responding to your presentation. Can you elaborate on how you made a script using the Sauce API to check for test flakiness?
Oh yeah, for sure. So that was actually one of our engineers, Laurel. She had put together a little Ruby script that runs through it uses the Sauce Labs API to say, hey, here, give me this range of tests, and then it says, for this test, what was the feature, what was the browser, and did it succeed or fail? And so it basically just calculated based on that what was the flakiness level across all those different tests for that specific one. And then it has some caching logic to make sure it's not hitting the API too much. I'm sure some engineers at Sauce Labs are like, please do not hammer our API. But yeah, so we found that pretty useful. Yeah.
Great. Neil, I know you've got an example as well.
Yep. So one strategy some of our customers do use is every time a test fails or fails intermittently, they log it to a database. And over time, you can query this database to figure out, assuming that you put the test name in there or test ID and the assets you can get from sauce, as well as the stack trace and test result report. So if you have all of this thing in one place, and you can gather this data, you can query it over time to figure out what is the trend or the failure that is causing the intermittentness or flakiness.
Sounds good.
That's a great idea. I learned something today.
There you go. Sharing is caring. So, Brian, Carson asks, how do you reset your test data?
Oh, yes, that's a great question. So in our case, actually, we don't do too much of that. So when we run a given test, all of our, as I said, we came into this kind of just figuring out as we went along. So I wouldn't necessarily follow our implementation as best practices. But yeah, so we basically, for our tests, if we create a user or something like that, I think we just leave it around. Certain tests we'll actually be able to delete them. What we found was in our case, we have kind of a special scenario where spinning in a given test instance, requiring all the things that will be required to make database calls from within a test to stub the data ends up taking longer than just clicking around the UI and creating a user, for example. So we ended up kind of leaning towards just having the test itself perform manual actions on the test machine. So in our case, we don't want to run the test against production. And for the most case, when we do rebuilds, like on CircleCI, it's doing a full rebuild. You're starting with a fresh database every time. In our case, we just need to make sure when we're running tests that we're using separate users, separate sections for everything. And so basically, we don't reset. we just keep everything separate, and that works for us.
Got it. Okay. Why don't we grab one more here, and then we'll pretty much finish on time. And I think this goes back to an earlier point you made, Brian. How many CircleCI containers do you have dedicated to your project, and does that create a restrictive funnel for pushing more features into your application if tests take 20 to 30 minutes, especially if you don't have so many CircleCI containers?
Right. So that's a great question. I think right now we're on 12 or so containers, and we haven't found it too restrictive. And we try to be pretty judicious about including CI skip when possible, and failing fast enough when a given test has gone rogue and is failing, and is still trying to run some of the UI tests. But we haven't found that too restrictive. But yeah, it's kind of I think that also ties in well with the question of how many tests do you run and over how many browsers do you run your tests for every single commit. Something that we found was because we're running our main test just in the test branch, what you can do is just run the test on a certain main pipeline branch, and it's going to be kind of similar to what we were doing before. Or you can run more tests on the main pipeline branch, but then you still have the issue of someone's got to monitor that and figure out when stuff broke. So yeah, it's a great question though. It's definitely a trade-off. Do we still have Bill?
Yes, sorry. Had the phone kick off. So one last one for Neil just came in. Running for each commit using Sauce Connect, how do you configure your test to automatically fire against that new build?
Yeah, so what you can do is every build at the beginning, it'll launch a Sauce Connect instance, and you can use your own tunnel identifier based on timestamp or the build number and job name. And at the end of every build, you can decommission that Sauce Connect piece. So the build should be responsible for that. And we have a CircleCI plugin that will actually launch Sauce Connect and decommission Sauce Connect at the beginning and the end of every build. And we also have one for other CI systems as well.
Excellent, excellent. All right, well, we're pretty much finishing few minutes past the hour, but thank everyone for joining us. Thought it was very well done, and we will go ahead and send out a link to the recording and to Brian's slides in the next couple of days. Just want to thank everyone for participating. Thank Brian and Lev and Neil for helping out. And with that, we'll sign off and ask everyone to have a great week.
Thanks, everyone.